In this video I'm going to talk about creating an ultraviolet colour checker and also creating a custom PTFE white balance standard for use with ultraviolet and infrared photography. I don't advise making either of these, but I will explain sort of why I made them and why I don't think it's worth making them. So to begin with, here's a colour checker, which as you can see, sort of it's got different colours on it, and it's got sort of black to white on it, and you can use it for making sure that your colours are correct in visible light photography. When you photograph it in ultraviolet though, it's pretty useless, and the neutral patches which you would normally use for white balancing an image are not neutral anymore. So we need a solution for doing that in ultraviolet. The standard way of doing this is with a PTFE standard. So here we've got one from LabSphere. This is a Spectralon standard, and this is a grey one. Now the issue, these are very good, but the issue with them is they're quite expensive. I got my set second hand. It comes in a nice wooden box. I think probably one of mine is missing, but obviously this is a bit large for taking around with you if you're taking it out in the field at all. The other thing is sort of this size standard, although it's fairly useful, it is quite thick. So this is the ultraviolet colour checker that I've created. So it's got a piece of opal perspex as the lid, and the idea of that is just to, because I've made the colour checker is made out of filters, so these can be unscrewed and used as normal filters, and this piece will protect them, and you can also take it off and shoot your flash through it to get diffused flash. So the idea with the colour checker is this base piece. It's made of two pieces. The base piece is made of PTFE, which is neutral in ultraviolet, visible and infrared, and the top piece is made of normal perspex, which appears blue in ultraviolet. In ultraviolet, obviously you can't see real colours, but as a general standard, sort of the nearer it is to visible light, sort of violet and deep blue, the colours will appear blue, and the deeper into ultraviolet you'll get more sort of yellow and green colours. So what we've got here is we've got a ZWB1 filter which goes quite deep into ultraviolet, probably deeper than my camera can see. Then we've got a ZWB2 filter which doesn't go quite as deep, a ZWB3 filter, and then this one is the ZB2. And then here we've got an infrared filter, 700 nanometer. The idea of this one is when we're testing ultraviolet filters, we can see if they leak infrared or not. If they do leak infrared, then this will not be completely black, whereas if they don't leak infrared, then it will be black. And then finally we've got the grey PTFE standard that I created. If you're trying to create a cheap sort of DIY one of these, you can't buy grey PTFE, at least not that I've been able to find. You can only get it in white. So the way that I've created this is to take some carbon powder, which is sort of a charcoal powder, and some PTFE powder, and then I've mixed them together, and I've used some optical glue which is transparent in UV, and as you can hopefully see from this, if I just unscrew it, this side is the surface. So this side, the surface I've sanded down slightly, but it's quite a rough surface on it. Unfortunately, the mixture does not dry smoothly, and so I've sanded down part of it just to sort of give me a slightly more matte surface. Again, if we compare it to the LabSphere standard, you can see the LabSphere one is much more matte, and sort of whichever direction the light is shining on it, it reflects the light pretty similar. You don't get any sort of reflection off it. So that is one of the reasons why these LabSphere standards are so expensive. The other thing is I've only made one of these, and obviously with the LabSphere ones, sort of they do come in all different brightnesses. So that one's almost white, and you get different grades of them, which you could use if you wanted for checking the exposure on images and that kind of thing. So basically this setup means you can, if you're testing a lens or a filter, you can see how deep the ultraviolet will go on it, and you can see if there's an infrared leak. It's not actually very useful in terms of checking, sort of keeping a consistent colour between images and that kind of thing, other than the fact that you can do a white balance using this grey standard. When I have compared this against my LabSphere standard, it is not as accurate as the LabSphere standard, which is to be expected. You can see there's 3 spare spaces here which I haven't used, so I could use those in the future, but at the moment they're just sort of white PTFE, which again you can use for white balancing if necessary. Now the main reason for having a grey standard is obviously if you're taking a photo, I use flash a lot, and if the exposure is too bright, then you're not going to be able to get a good white balance. If you're using a grey standard, then you don't really need to adjust your exposure at all. You can just take a quick white balance photo and it should be somewhere in the range of middle grey, so that you can get a white balance off it. So it was a lot of work and a lot of expense creating this. I mean, the carbon powder and the PTFE powder are very cheap, or fairly cheap anyway, but the optical glue that passes UV light, or doesn't block UV light anyway, was very expensive, and so it's not really worth creating one of these. What you can do is just get a cheap piece of PTFE, and then just for your white balance photo, just reduce the exposure a bit to ensure it's not overexposed, and then white balance off that, and that will give you the same result as creating one of these, except it's loads cheaper and you don't have to do any work trying to make it. And the whole ultraviolet colour checker is not really that useful in terms of taking UV images. What it is useful for is for testing lenses and testing filters. So since I've made it, I will use it for that. But honestly, you could achieve the same effect with just a piece of PTFE, a piece of white perspex, and a couple of filters, and just take photos of those rather than having something specially made up.